So let's begin. What we need to understand is what is advanced predictive modeling and how it's different from normal predictive modeling. So what we'll do in advanced predictive modeling with R is will not only contain or confine ourselves with basic regression or basic forecasting, but we'll go deeper and try to use almost all possible kind of data set available or in the real life and try regression on it. So, or maybe build a model on it. So when you do a basic forecasting or basic predictive modeling, we clean the data, we assume the data set to be very, very superficial, and we assume the data set as per our convenience and then do our modeling. But in this case, we'll take up real life data with the maximum distortion possible, maximum missing values, and maximum noise possible, and then try to make models on it. Because in real life, the data set which we'll get have, numerous kind of anomalies. It will have a lot of handicaps, it will have a lot of bottlenecks, it will have a lot of missing values, it will have a lot of errors, it will have a lot of noise, and we'll try to understand how to do it. However, in this session, we'll not be able to cover all aspects of predictive modeling, but we'll try to understand a very basic thing which we call forecasting. We'll introduce you to predictive modeling. We'll go beyond ordinary least square regression. We'll decode forecasting. We'll understand how to take forecasting. We'll take two real life data set, two examples for that matter, and make forecasting models in R and understand forecasting techniques and plot. We'll do it manually also, and we'll do it automatic also. Right? Okay. So when you see, I'll go to my R, we'll swipe between my R screen and this presentation, right? So when you see a data set, for example, I have this data set, a particular data set is what? A particular data set is more like you have date at one column and then you have the values another column. So for example, demand. So I'll have demand for every, and I have the particular respective dates for those demand numbers. Now, if I want to convert that into a forecasting problem, I need to first convert into a time series data, right? So what is a time series data? A time series data would be something like this. Now, I think so, right. So time series data is something like this. So I took a random number 1 to 500. And I wanted to, not random, the serial number 1 to 500, wants to convert it into series data. So I say frequency equal to 12. Why? I want to take it a monthly data. So I took 12 months, start from 2011. So it is starting from 2011 and from the third month of 2011. So if you see January, there is no value, Feb, there is no value, third month of 2011 starting, right? So that's a time series data. Now what if I make it 4 and then again do it? So if you see, if I make it 4, what happens? So it becomes a quarterly data, Q1, Q3, Q4, starts from the third month or third quarters for this matter, and start from 2011 and will run up till when it reaches 500. So the moment it reaches 500, it will stop. So it reaches 500 in 2021-36, quarter 2, right? However, for our understanding, we'll keep it monthly, and we'll try to print this. Also, we'll try to understand what this data is all about. So when I write str8, shows that yes, it's a time series data with values ranging from 1 to 500, year from 2011 to 2053, and so on and so forth, and gives me the list of all the data, right? We'll see the attributes. So when we see the attributes, okay, it says it's a time series data and it starts showing me the year. So it starts from 2011, ends up to 2052 and 12 months. So this is the beginning, this is the end, and this is the frequency, right? And classes, of course, time series data. Now let's plot this data. This plot would be a bit different from this. So we have increasing number 1 to 500 and increasing time. So the number increasing. It's as simple as that, right? No rocket science. So this was very, very basic time series data, which is also in my PPT. So what I did, I took one data set with any number. So here I took 1 to 20, 12 frequency, start from 2011, third month, print. So it took the, it started from 2011, third month, and went up to 2020. That's it. And 8 digits, that is 1 to 20 are my data set. One, it talks about the TimeSeries data and then attributes. Right? Now we'll do a real life example. So I have a data set which is called air passenger data. So if we let's look at this data first. So we'll look at this data. So these are air travels, 112, 180, 132 number of people traveling and something like that. So I have these numbers all across, 144 records and one variable. So it's just simple one column record. Now what I'll do is I'll first see what is this. It says it's a time series data. Let's see the data set. It shows me the minimum and maximum values. I'll view the data set. It shows me the data set, and I'll plot this data set. So it shows me the plotting. So this is how the data set look like. Now what I'll do, I'll convert this time series into my system of time series, right? So this is the annual data. I want to convert it into, say, something like, so APTS is basically nothing but air passenger data, and I convert it into time series. So what I did, I took 12 months and I told to take all your 144 data numbers or observation and bring it down in monthly order. I have not specified a year. If you want, you can specify a year. How do you specify a year? It's simple. Start equal to your year and from where you want to start. However, I do not care what's the year all about. It does not matter for me as of now. So it's just simple, time series data. So get monthly time series data. You want, you can try a quarterly, but this is a monthly data. So I took a monthly data, right? Now I want to decompose the data. Now what is the decomposition? I'll come here. Similarly, this I've shown you how to make this chart. It's very simple. I plotted this time series data and I got this chart showing that there's an increasing trend across the year in passenger. However, in each year or in time, every time there's a peak and there's a fall. There's a peak and there's a fall. So it's not very, very smooth, but yes, overall this is the increasing trend. Now what I want to understand, that in this previous diagram, there can be many things. Number one, there's an increasing trend, which you can see. So that's called trend. In a time series data, there's something called trend. There's something called seasonality. If you see every couple of months or sometime it's falling down and coming up. So there's a seasonality. And there is something called unexplained randomness. So there's a randomness, a random behavior, random purchase behavior. So in time series data, there are three things. Something called a randomness, seasonality, and trend. So this is what it explains here, right? Now let's move forward, right? So what I did, I decomposed the data. So when I decompose the data, it shows, okay, the data has seasonality, trend, and randomness. Figure is the original figure and time is the time series data, right? And then I'll try to plot this and I'll see that, okay, this is how my data looks like, right? I'll show it in R. So I've decomposed the data. If you see, so data has been decomposed. So I'll show you the entire output. Yeah. So when having decomposed the data, these are the original values. X is the original value. These are the seasonality. So it shows that every few months it falls and that increases. So these are the seasonality. Seasonality is a behavior in a particular season, month, period of time. So it talks about here is the seasonality, right? It talks about trend. So there is a trend. So there is an increasing trend. I think so. Yeah, there is an increasing trend. So there is a trend also, and there is randomness, random behavior. So if you see, there is nothing. So minus 42, then 8 positive, huge increase, then decrease, then a huge negative decrease. So these are random behavior, which I explained. So in every time series data, there will be a randomness, there would be time, trend, and there is seasonality. So when we solve this for the first time, we were not able to understand that there are multiple components which make this data set. So now we see there are three, prominent component which makes this data set, right? So additive, there are two ways of doing it, additive and multiplicative. which we'll understand when we get deeper into the course, but by default people use it additive, right? Right, so this shows me things, and then we'll try to, we did this plotting. I showed this plotting in the PPT, and then we'll do a better plotting. So if you see my screen, so this was my observed data, right? So I took out the trend from the observed data set. I took out the seasonality. So if the seasonality is flat, because we took out the trend, and then we took out the randomness. Now, if you combine the second, third, and fourth block, it will become the first block. The first block is equal to second, third, and fourth block. So this would give me the trend. Put this above this, it will become seasonality. Put this on this, it will become randomness. Now, if you see, seasonality is very uniform. It's decreasing, increasing at almost, but here it was not similar. Why? Because we added this randomness. And these both are flat. However, it is increasing. So why? Because we added this trend. So we decomposed it into 3 different components. Okay. Now we will try to build a model out of it, right? So we did this. So what would be a model look like in this case, right? A model is called an ARIMA model, which is called Autoregressive Integrated Moving Average Model. So this is the basic of forecasting model, which is ARIMA and ARIMA model. So what, going by my understanding and knowledge, what I did, I manually fit a model. So the manual fit model will be called AirPassengers, my data set order 100. Now why 100? So if you see, ARIMA is made up of 3 words, AR, then I, and then MA. So this is AR, this is I, and this is MA. So, and by my understanding, by seeing the graph, you'll all understand later on. But right now, let's take it. I'll try to make one more graph for you if possible. Right. So this will not work here. So let's not do this. Okay. So this is my AR, this is my I, and this is my MA. So I say make one AR model, 1 lag ARIMA model, or 1 lag AR model, autoregressive model. And I saw there's a seasonality also. So 2 lag AR seasonality, 1 interval, and no moving average for 12. So I'll run this, right, and I'll see the output. So as you see, I told him to make AR1 models. It gives me AR1, no intervals and no moving average. So there's nothing like that. I told him to make two seasonal AR models. So ARIMA. So it gives me seasonal AR1, seasonal AR2, and it gives me an output. Right? Now I say use the model which you made on my. So I'm not the best model. It's just a first attempt model. So use this first model which we did and forecast for the next 24 months what would be my output. So this is what is my forecast for next 24 output. I'll try to plot this also, but I'm not sure that this will not get plotted like this. So what we do in plotting, we take the first one. We'll do the plotting in a while. Yeah, I have the plot codes also, right? So what I told it to give me the next prediction for next 24 months. So if you see, it gives me the prediction for 24 months along with standard error, which is confidence interval, right? Now let's talk about the standard error. So I want the upper limit. So the forecast prediction value, this values plus the standard error into 2. That is my upper confidence interval, and this is my lowest confidence interval. Because I cannot say that 641 people would fly down in July 1961. That's a nonsense way. I should say that between this and this. So let's see what's the between thing. So I'll be able to say, okay, so 1961 in July, your figure would be something between 606 to 503. That minimum 503 people would fly, maximum of 606 would fly. So I give a range that looks much better. Now what I do, I make a graph. Let's see. So this is called a TS plot graph. Yes. So I made a graph. So if you see, this was my normal data, and this the red line are forecasted, and this blue line are the confidence interval. That the data or this forecast would lie between these blue bands. So just to make it much more clear, what I'll do is I'll also put a legend, right? So if you see now, this looks much better, right? So that is how things look like when you were forecasting. So that was one data set. So what we did an AR1 model and seasonal AR2 model and took out the output. So this is AR1 because this was AR, then 0, 0. S is seasonal AR1, seasonal 2 because here it's 2, 1, 0. So AR seasonality. So seasonal equal to this and order equal to this. Order is by default and seasonal is if you want seasonality. So we saw there's a seasonality. We did the forecasting. We did the prediction for next 24 months and we took out the standard error. We took out the upper limit and the lower limit, 95% confidence level. We did the graph and we saw how it will react. And if you want to see the actual values, here are the actual value. If you want to see the graphic, here is the graphical, right? Okay. Now there's one more data set we'll talk about, which is called Euro retail data, right? Now before we go to Euro retail data, let me know if you have any doubts still here, and then we'll try to move forward. Any doubts still here? Anybody? Right. So I have a couple of questions. I think so. Let me first answer them, and then we'll move forward. Okay. So people are talking about the back and all out here. So they are students who are, they are attendees who are, from .NET platform, UC, hash, and, talk about decision tree, algorithms and everything, right? So Paramjit, if you can look into this and see how you can do a student placement forecasting also here. I think so you can use ARIMA model sometime and test your forecasting model also, right? Anyway, so I don't have much questions here, so we'll move forward and then we'll come back to question. Please type in your questions, ask any doubts you want to get into understanding, you want to connect it with your workplace. If you have any real life problem in your workplace which you want me to address in this small session, we can take it. Right. So we'll take one more data set, right, which is called the Euro retail data set. So let's see. So I have around a couple of years data for 4 quarters. These are sales, and I have this TimeSeries data already. So I'll make out of it. Okay, I see there's an increasing trend and there's a decreasing trend. Now this trend again also have a lot of things inside it. So now what we'll do is I'll differentiate the data. That is, I'll take the fourth differentiation model. That is, take the fourth value minus the first value and so on and so forth. So every fourth value would be subtracted from the first value. So if I have 10 values, so the fourth would be subtracted from 1, the 5th would be from the 2, the 6th would be from the 3rd, and so on and so forth, right? How did we come to this conclusion? We'll come to that in a while, but this is called lags. So I'll take lag, right? So I'll take the first lag and we see this. So I took the lag and I saw that, okay, this is the difference if I take lag, and this looks much more smoother to me. So this is called ACF plot and PACF plot, auto correlation factor. How is the data correlated automatically? Partial auto correlation factor. Now what is correlation? Is in simple word, when we do all this, in the first one, what I'm trying to understand when I take fourth lag, that I say that my fourth quarter result is based on the first quarter result. That is, whatever my pattern of purchase would be in the first quarter, it would affect my purchase in the fourth quarter. So that is how we have talked about it. So that is auto correlation. It is very simple, that your last year performance would be somewhat related, or basically your this year performance would be somewhat related to your last year performance, which is very, very true. For example, how much you get in your final exams also depends on how much you get in your midterms, because midterms shows a idea of how much you get in final exam. So this is what I'm trying to do, which is called auto correlation factor, and that's fourth lag. The next one I'm doing is difference of fourth lag. right? So again, if you see, so this looks much more smoother, and I see, okay, so what I did, I removed the autocorrelation here. So if you see, I don't have a proper autocorrelation. ACF is random, PACF is random. Initial part is you had a decreasing trend of ACF. Here what I try to say, that my data for the fourth year of fourth quarter would depend upon the difference of fourth and the first quarter. I'm trying to remove the noise in this case. There's multiple way of doing it, but this is one of the most practiced way. Right. Now what I did, I will come to the PPT, it will be much more easier. So we did this, we saw the graph. We did a fourth lag differentiation. We did a fourth lag differentiation, right? And we understand that, okay, when I did this, I going by my idea and knowledge, I understand that there is a seasonality here, and seasonality is that moving. So we had this ARIMA, you remember, ARIMA. So I said this time I said, okay, this is not AR model, this is MA model, moving average model, but MA1 model, right? So if you see, AR is 0, I is 1, MA is 1. Here I did not take AR model, I took MA model. So ARIMA, ARIMA. So this is MA1 model along with seasonality of one model, and every fourth season or every fourth quarter or every fourth time period it shows a seasonality, right? So we will try to do this. Now what we'll do is, alright, so again AR0, I don't want an AR model, I wanted an MA1 model, and similarly seasonality MA1 model. Now let's see. So I got MA1 model and seasonality MA1 model. I do not have an AR because AR is 0, 0 here, right? And now I'll do I again made a graph where it shows, okay, there's no autocorrelation, there's no seasonality, and this graph shows me of residuals. The residuals are what? The actual number minus the fitted values are called residuals, right? Now we'll tweak the model a bit. So what I'll do is, I'll come here, so this was the graph, we'll tweak the model. So initially MA1 model, this time I'll take MA3 model, while seasonality I'll keep it MA1 model, right? Last time if you remember, we took AR seasonality AR1 and seasonality AR1 and seasonality AR2. So we took AR1 and second order seasonality. Here we are taking, normally we are taking third order moving average, but let the seasonality be first order, right? So when we run this, will be clear, right? So here if you see, so I took for third order moving average, so average I'm getting 3, third order MA1, MA2, MA3. However, seasonality I'm only getting once because I gave it one order seasonality, right? Again, I got the graph done and understand that, okay, these are more or less similar, that it has not brought in any changes. I do a junk box test. It is to see that you have an auto correlation or not. 7 is a very low number, so accepted, not an issue. So I'll use the last one, this model. I use this model and forecast for the next 12 periods. So I've set for this next 12 period. For next 1 year, this is my forecasting, this is my range, and this is my forecasting. Right? Now this looks good to me, right? So I took this model, MA3 model and seasonal MA1 model. I made the graph, did a junk box text, and then I did a forecasting for next 12 months. Right? Now this looks very, very good to me, but this is a manual intervention and people who are new into this business may get confused. So is this a way to cross check that I'm doing it right or not? Or all this, you know, all these things, yeah. So all these numbers we're taking MA1 model, MA3 model, seasonal MA1 model, AR1 model, AR2 model, seasonal AR2. Am I doing right or not? Or have I done some calculation mistake or eyeballing mistake? So can R tell me automatically? Yes, it can. How? Right. So that's called auto ARIMA. So when I run auto ARIMA for myself, what it top, so it will take some time. Okay. So the auto ARIMA says that, okay, what you need to do is you need to take an AR1 model and MA1 model and seasonal MA1 model. So it says take an AR1 model, so AR and MA1 model also. But when it comes to seasonality, take only seasonal one model. However, this is based on average. It's approx. It's not accurate. So what I do, I say, okay, no, give me the best model. Don't give me this model. Give me the best model. So I tell approx off and stepwise off. Now what I do, I see this. See, now it matches my, prediction, or basically my analysis. It says that no AR1, so one difference, and MA3 model and seasonality MA1 model. This is what it talks about. I thought, yes, I'm right, so I can give a pat on my back, and then I do the residual plot, I do a junk box test, same thing, and then again I make the graph. That is how I do it, right? So before we go forward, let's see this. So I did this initially. This was an approach. This is also fine. The difference in the data set would not, the difference in the output would not be much. But when I have to do a very, very close forecasting, I'll make approximation of, and I'll make stepwise off. I'll give me most concrete answers. So this is how it will do it for me. So my object, or my projections, or my ideation was right. So what I understood manually is what computer tells me automatically also. And you can see, how do I know this is much better? If you see AIC value, AIC is 67.4, which is less than 68.37. The lesser the AIC, the better the model is. So that is how I understood that, okay, this model is a big tick mark for me, right? So this will be my final model, and then this would be my final forecast. So that is how I do it, right? Now, any doubts before we go further? Anybody? Right. So Paramjit has a question. This model sounds good on numerical data with a time series as we predicted. My question is that, can we implement on my project? There are a number of attributes like core skills with multiple choice option as excellent, good, average, and poor. So in Paramjit, in this case, we'll not use normal forecasting, we'll use multinomial regression analysis, right? Since Likert scale kind of data set also, in that case, we basically use multinomial forecasting. So we'll come to that in a while, right? So this was the entire thing. So I have one more data set which is on medicine, which is basically some Australian drug sale medicine. I wanted you to do it yourself. So it's very simple. Now this takes plenty amount of time because it's a heavy data set. I think so this will come now. Oh yeah, let's come. So we'll take. So what I did is I took an auto ARIMA model for the data set, wherein I told you, okay, predict, no approximation, predict me the output. So I'll not run it together. I'll just go here and check. Okay. Right. So it will give me an output. It will tell me an ARIMA model, but whatever the ARIMA model is, I'll make a graph out of it. I did a junk box test for this. I used the same model, the fit model, right? Which it gave me. It was an AR3 and MA1 model, and for seasonality, it was MA2 model. So AR3 MA1, comma S MA2 model, and then I plotted the graph, which looks something like this. This was the graph. So this is how it looked like. If you want to see what was it, I'll just try. It's in the memory. Yeah. So it talked about, the model was AR3 yes, MA1 yes, and then seasonal MA2 model. So it was this what it talked about, and then it made this forecast and told that this is how your sales would look like with the confidence interval. Now what is this 12? That every 12 month you have a seasonality. There's a 12-month data, that is, it's a monthly data. So that's what 12 represents here. In the initial it was 4, it was a quarterly data. Thank you so much, guys. I hope you enjoyed the session and you got a basic idea what this module is all about and what's predictive modeling is all about. This is the basic of basics which we did. And take my words, when you do this, it will be an end-to-end thing. You'll start from basics to intermediate to advanced level. And once you complete this, everything else in this world would seems very easy when it comes to predictive modeling. Right? Thank you so much. See you soon.